Hey guys, Thursday, May 14th, and this is the last day of the week for school. Tomorrow's a Pro D day. It doesn't really, it's kind of weird to have a Pro D day, but we will be working here. Teachers will be working at the school on a lot of this stuff, on how to better create these digital lessons and make contact and all kinds of things like that. I've got a few things I'm going to try that we can experiment with the following week. Okay, so here we go. A couple of things before I begin. I'm going to flip over to the home page here. This is from Wednesday. There's some reminders. Remember that I'm available every day from 11 a.m. to noon. Come on Google Meet. I just turn it on and I leave it there, and kids come and visit or get math help or just check in or just say hi or whatever. So it's good to see your faces. Miss Olson has the same hour a day, but it's a different. Some days it's 10 to 11. Some days it's in the afternoon. So check the Google Classroom for her times. And then we're doing a full pod Google Meet this Thursday. Today at 1 p.m. So come and join in. Okay. Back to math here. Here's today's work, and I put a priority list. Is it taking me back? There we go. The internet is very slow. Holy cow. So priorities for today. Watch this video, and you're here. So perfect. Check one. Catch up on any missing work for the week. So if you haven't done this work package, there's not that many questions in it. Literally, there were some days with like 3 questions, some with 2 or 4. There's not a lot to do. This is the answer key here, and we'll click on that in a minute. If I go back to yesterday's, here's the actual work. This is just the blank. Both of these are the same, page 241 to 246. Some of it is not work. Some of it's just pages of explanation or an intro to this idea of tree probability, and we'll get to that today. But they're just helpful pages that would be good to read through. If you're struggling at all, read through them. Don't just give up. Read through those pages, okay? So that's the first thing you're going to do. Catch up. Or this, remember, if I click on this link here, this takes us to a simple probability page. And more than half of you have done it, but there's still a number that haven't done this page. And it's really simple. It's multiple choice. I just want you to do your best with it. Try to figure out the questions and then hit submit, and you'll get your results right away. There's a little button that says get results, and you can see how you did. Okay. So I want you all doing that just so I know that you're engaging, you're keeping up to date. Okay. Now for today's work, I'm not going to click on this one. I'm going to click on this, which is the same, but it has the answers. I made up an answer key for it. So let's talk through it. Page 241, number 2 says, list all the possible outcomes. So throwing a 3-sided die, which is impossible, but that's okay. And numbering 1 to 3, and then flipping a coin. So you could have a 1 on the die and heads, 2 on a die and heads, 3 on a die and heads, or pardon me, not, yeah, that's right. Or a 1 and tails, 2 and tails, 3 tails. So you could do it either way. You could have done the heads and a 1, heads and a 2, heads and 3, tails and 1, tails 2, 3, or the other way around. It works out to be the same thing. There's 6 outcomes though. Combinations of numbers when you flip a coin and roll a die. So you could have you could have a number 1 in the heads and a number 2, or number 1 in heads and a number 1 tails, number 2 heads, number 2 tails, number 3 heads, number 3 tails, right? There's 6 outcomes, and there's a heads and tails for each one of those outcomes. Now there is a shortcut to this, and we'll get to this today. Same with this. When you roll 2 die, there are a lot of different outcomes because I separated this into red and blue. So I have a red dice, right? 6-sided, and a blue, regular 6-sided, and I'm going to roll them at the same time. Now, they're not going to come out in this order, but I kept it in order so you can show all possible outcomes. So if you get a 1 on the red, you could get a 1, 2, 3, 4, 5, 6 on the blue. So there's 6 different outcomes with a 1 on the red. If I got a 2 on the red, I could also have a 1 on the blue, 2 on the blue, 3 on the blue, 4 on the blue, 5 on the blue, 6 on the blue. Okay, so there's 6 different outcomes when I have a 2 on the red. There's 6 different outcomes when I have a 3 on the red. I could have all of those outcomes on the blue. So as I work my way through, there are 36 different outcomes. And that the shortcut for just calculating number of outcomes is multiplying each one together. So 6 outcomes on one die, 6 on the other, 6 times 6 is 36. And that works up here too. A 3-sided die and flipping a coin, 3 outcomes times 2 outcomes is 6. Or heads and tails, there's 2 outcomes. Rolling a die, there's 6 outcomes, right? So 2 times 6 is 12 outcomes, okay? Now this, a little bit different, but same kind of thing. A marble is picked from a bag containing 1 red and 1 black. So I can pick a red marble, and then there's 2 coins, first coin and second coin. So I can have a red marble and then heads on the first coin and heads on the second coin. Or I could have a red marble and the heads on the first coin and tails on the second coin, right? Heads and heads, heads and tails. Or red, and I could have tails and heads, or red and then tails and tails. So there's 4 different outcomes I can have when I pull a red marble out. The same number of outcomes can happen when I pull a black marble out. The only difference is I have a black instead of red. So there's a total of 8 outcomes, 8 different ones, and that's the way you list them, okay? To shortcut it, there's two outcomes for marbles, red or black. There's 2 for this first coin, heads or tails, and there's 2 for this one. 2 times 2 times 2 is 8, okay? List all the possible outcomes when these pointers are spun. So I could have an A on the first one and a 1, or an A and a 2, or an A and a 3, or an A and a 4. So there are 4 outcomes when it lands on A. There are 4 outcomes when it lands on B, B1, B2, B3, B4. And there are 4 when it lands on C, C1, C2, C3, C3, 4, C4. So there are 12 possible outcomes, and that's the way you list them. Now, the next thing we're going to do is go to this tree method, which shortcuts this a little bit. It's the same idea, but you don't have to rewrite things quite as much. And it works like this. So let's say we had this same spinner, A, B, C, right, on the spinner, just like this one, and 1, 2, 3, 4. I could list it like this. Instead of A1, A2, A3, A4, I can just go A, B, and C, because we know that that's the first spinner. And then for each one of these, I could get a 1, 2, 3, 4. So I can see all my 12 outcomes like this. A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. Okay, just shortcuts it, makes it organized. Okay, so using a tree diagram to show the sample space when a nickel and a penny are tossed. So I have 2 coins, a nickel and a penny. So here's my start. I could have a heads and a tail on the nickel. And then if I roll a heads here, I could also have a heads or a tails on the penny. So there's 2 outcomes if this lands on heads. The same is true for tails. If I get a tails in the first one, I can still have a heads or a tails in the second one. So there are 4 outcomes: heads, 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 tails, tails, heads, tails, tails. And that's the way to list it, just like that. That's a tree diagram. Okay. Or this one here, use a tree diagram to show the sample space when a penny and a spinner is spun. So you got a penny times 4 different outcomes. There's going to be 8. So I can have a heads and a tails, and I can have a heads and a 1, 2, 3, 4, or I can have a tails and a 1, 2, 3, 4, right? If I was going to write this out, I would say heads 1, heads 2, heads 3, heads 4, tails 1, tails 2, tails 3, tails 4. But there's 8 outcomes both ways. This just simplifies it, okay? It's especially simplified if you have lots. So here's a die. I have 6 outcomes, 1, 2, 3, 4, 5, 6. And then for each one of those, I could have a red, a green, or a blue. So 1 red, 1 green, 1 blue. 2 red, 2 green, 2 blue. 3 red, 3 green, 3 blue, right? All the way down. So you can see that there's 18 different outcomes, or 6 times 3 is 18, okay? This one here, we have 3 different things we're doing. So we have a dime, we have a nickel, and we have a penny. So you can just start with one of them, and I started with a dime because that's in order. So a dime, heads, and tails. If I get a heads in the dime, I can get a heads in the nickel or a tails in the nickel, okay? If I get a heads on the dime and a heads in the nickel, I could also get a heads and a tails on the penny. Okay, so you can have heads, 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 or you can have heads, heads, tails, or I could have heads, tails, heads, or heads, tails, tails. Those are all the combinations of it when it lands on the head side for the dime. Now the same is true for tails. I can have all the same ones. I can have tails on the dime, heads on the nickel, heads on the penny, or I could have tails on the dime, heads on the nickel, and tails on the penny, or tails on the dime, tails on the nickel, heads, or tails, tails, tails. There's all the different outcomes. Okay. And then lastly here, so we're going to draw a black or a red card from 52 cards. Doesn't matter the amount. It's either black or red. So 50-50 chance of either one of those. And then I'm going to draw from another pile with 5 cards, A, E, I, O, U. So a 1 in 5 chance for those. So I can get a black and an A, black and an E, black and an I, black and an O, black and a U. So there's 5 chances with black and the same 5 chances with red. So there's a total of 10 outcomes. That's it. There's nothing more to learn with this probability. The tree method shortcuts it. You just keep adding. If I had 2 coins and 2 dice, then I would just organize it all. I would have heads, heads, 1, 1. Heads, heads, 1, 2. Heads, heads, 1, 3. Heads, heads, 1, 4. Right? Heads, heads, 2, 1. Heads, heads, 2. Heads, tails, 6. Like what I'd have to do it in order, but there'd be a lot of different outcomes. But it doesn't change the way we do things. Okay, so back to our main page here. So make sure you do that. The Google form from last Thursday, which is a week ago. If you haven't done that yet, you are a little behind. Second step, you have a 3-day weekend to get caught up from this week's work. I'm going to do a quiz next week on probability, so you need to be ready for it. This is important stuff moving forward. If you're done everything and finding it quite easy, then I have this page for you here. It says couldn't view file. That's weird. I'm going to have to go in and see if I've taken the permissions off it. It's a bonus question, and I'll do that right away. And if you want, you can just do the bonus question, submit it to me, what the answer would be and your explanation. And if we get back together this year, I promise you candy. If we don't, come see me next year and I'll give you candy. And I'll get included as a bonus mark in your term 3 math. So there's some incentive for you to do that. Okay, I think that's about it. Make sure you stay caught up. Make sure you stay safe. Make smart choices. Hopefully we'll be together. I hope. I really don't know. But we'll talk to you guys soon. I miss seeing you. And make sure you come to the Google Meet because I love to see your faces. Okay, take care, everyone.